Hello my dear students, I hope the first two sessions have helped you in preparing for the board examination 22-23. Today I will be covering chapter number 3 from the chemistry part, class 10th standard science NCERT textbook, which is metals and non-metals. I will be covering only the focus points. I hope you have practiced this particular chapter at least once. You have read completely from the textbook. Now if you go through this chapter, this particular focus points, it will certainly help you in the final time preparation. Here first you need to focus upon differentiation between the metals and non-metal based upon their physical properties, and pay attention more on to the exceptional cases which are available. Electrical conductance, you know, graphite is electrically conducting, which is a non-metal generally. It's made up of carbon, but it conducts electricity because of free electron which is available with the graphite. And lustrous property, that is ability to shine. Exceptions are diamond and iodine. Iodine being a non-metal, diamond is also being a non-metal component, allotrope. It also actually showcase shiny property. And the next one is hardness. Exception in this particular hardness is diamond. Diamond being a non-metal, it is very hard. Generally we know that metals are hard. Malleability, beaten into thin sheets. So all metals are beaten into thin sheet, non-metals cannot be. Non-metals generally are brittle by nature, that means it can break easily. Ductility, the metals can be drawn into thin wires, but non-metals cannot be. Sonorous, metal generally produces ringing sound, but non-metals cannot. Physical state, all metals are generally solid by nature, and non-metals generally available in all the three physical states, that is solid, liquid and gases. In specifically gases and solid non-metals are more in number, but liquid non-metal only well known is bromine, and only liquid metal which is well known is mercury. Melting point and boiling point, metals have high melting point, non-metals generally have low melting point. And in the case of softness, lithium, sodium and potassium are very soft metals, can be even cut with the knife, and this is maybe attributed to their less density and less melting point also. And generally oxides, metal oxides are generally basic oxides, non-metal oxides are generally acidic oxides, can be tested by using litmus paper. Chemical properties of metals and non-metal. Here I have divided this particular part into 3-4 sections, wherein first we will be dealing with how metals reacts with oxygen. So generally there are metals which reacts directly, like sodium, potassium, calcium, lithium, which reacts after heating, aluminium, magnesium, copper, iron, which are inert to the oxygen. They are gold, silver, platinum. And there are amphoteric oxides also which are well known, that is aluminum oxide. Amphoteric oxides are those which behaves both are acidic oxides as well as basic oxides. Generally metal oxides should be basic by nature, but here they showcase even acidic character by taking this example: Al2O3 plus HCl giving rise to aluminum chloride and water. Al2O3 plus NaOH gives rise to NaAlO2, that is sodium aluminate plus water. Even zinc can also exhibit amphoteric behavior. With water, there are 4 different types of division what we can have here. There are metals reacting with cold water, with hot water, with steam, and no reaction with the water at all. With the cold water, we may observe sodium, potassium, calcium reacting directly, and they may even sometimes catch fire. That's why they will be stored in kerosene. Warm water, magnesium reacts, and then it will be will also start floating on the water, as like calcium does in the cold water, magnesium does in the hot water. That's because of the hydrogen gas, what they releases will be making the bubble formation on the top of their surface, which brings the density of the metal down. So due to which they start floating on the water surface. And with the steam, we have aluminium, iron and zinc which are reacting with the steam. And kindly note, the chemical reactions with iron reacting with the steam is very important, because you may get confused with the rust formation with the iron reaction with the steam. Fe when reacts with the steam, that is H2O, in the presence of gaseous form, it will give rise to Fe3O4 plus H2. Okay, and there are metals which will not be reacting with water at all, like lead, copper, silver, and then gold, and even platinum. They won't react with water at all. Next one is reaction with acids. Whenever metals react with acids, they produce salt and hydrogen gas. And generally acids what we select here is hydrochloric acid or sulfuric acid or ethanoic acid or carbonic acid. But there is one special category, that is nitric acid. Whenever we take nitric acid, we get water as the byproduct. The reason is nitric acid being the strong oxidizing agent oxidizes the hydrogen getting released and then converts into water. But there are some special metals which will not be reacting, which will be reacting with dilute nitric acid but does not produce water. They produce hydrogen gas, that is magnesium and manganese. And we have a special note here, that is aquaresia, which will be combination of nitric acid and hydrochloric acid in 1:3, or hydrochloric acid and nitric acid in 3:1 ratio, which will be used to dissolve even gold, which is inert metal. And there are reaction based upon the reactivity series, displacement and double displacement, which you may able to do because it is already done from chapter number 1. And the next one is ionic bonding. Ionic bonding is mainly because of electrostatic force of interaction developed between metal and non-metal. Metal always loses electron, non-metal always gains electron. Metals forms cations, non-metals forms anions. And these particular substances can be represented by using Lewis-Strauss structure. Lewis-Strauss structure is those in which chemical symbol of the element is written against the dots of valence electron will be written on the top of it. And distribution of electrons will be done based upon how many number of, what is the valency or combining capacity of the element. So if the element is having less than 4 electrons in the valence shell, then they will be losing all those electrons. If the element is having more than 4 electrons, then they will be gaining electron to complete its stability, that is octet configuration they will try to attain. In specifically practice for magnesium chloride, which is given in your textbook directly, and calcium nitride Ca3N2. And also focus mainly upon the physical characteristics of this particular ionic compounds, that is physical nature, that is they are hard as well as they are brittle. Solubility, they are water soluble but organic insoluble. Whichever the organic solvent like benzene, ethanol, ether, if you take these things, they will not be soluble at all. Melting point, boiling point of this ionic compounds will be very high comparatively because of high force of interaction. The very strong force of interaction will be available, which is known as electrostatic force of interaction. And conduction of electricity will be done by either aqueous solutions or molten solutions of these salts, ionic compounds. But in the solid case, it will not be conducting, because in the solid case they will be available in the form of lattice or crystal. They will not be conducting electricity. And they exist, this happens because they have free ions existing in the aqueous and molten state, whereas in the solid state there will be no free electrons, there is no free ions, that's why. And the fourth important concept here we need to focus upon is corrosion. Corrosion is nothing but eating away of the upper layer or surface layer of the metal, and it can be done in 3 different cases, that is rusting of iron, green coating on the form of copper, or decoloration or tarnishing of silver. So these 3 are very important corrosion process, which will be given to you in the form of sentences. They may frame the question, or in the form of direct equations also they may give you. And how to prevent this corrosion is by using alloying or galvanizing, or by taking this particular compounds and then painting, oiling, greasing, etc. So many methods are there to prevent this corrosion. One such important concept here is alloying, in which the alloys of 3, 4, 5 I have given here. Solder, tin and lead, brass, copper and zinc, bronze, copper and tin, 22 karat gold, gold plus copper or silver, either of them. So here they may ask you reasoning question like tin and lead have high melting point if you take separately, but when they combine they have low melting point. What is the reason? Since we use solder in the case of welding process, the tin and lead alloy will be having low melting point because they burn at the very low temperatures. And you should be aware that 24 karat gold is the purest form of gold which will be available. And next one is anodizing. In the case of anodizing, what we generally do is we form a thick layer of aluminium on the top of any metal which is highly reactive. Here pure aluminium will be taken in the anode, and electrolyte we select is concentrated sulfuric acid, and oxygen gas will be getting evolved at the anode, and they will corrode the aluminium metal, forms the thicker protective oxide layer on the top of them. So that's how we can do anodizing. This concept is also important, pay attention to. And the last part of this chapter what we have given is extraction of metals. The extraction of metals can be divided into 3 different cases based upon the reactivity of the metals, that is highly reactive, moderately reactive and low reactive. Highly reactive metals can be extracted by using electrolysis. Moderately reactive can be used by reduction by using carbon, and least reactive can be used in their respective native state itself. But there are cases like silver and copper may be available in sulfide forms. So that can be directly taken by using reduction by using carbon, we can do it. So one important ore you should be aware of is cinnabar, that is mercuric sulfide. And you can also remember hematite and magnetite for iron ores. You can remember cuprite for copper, galena for zinc sulfide, and another zinc blend, galena for lead sulfide, zinc blend for zinc metal. All these particular words you can remember side by. And enrichment of ore can be done by removing all the impurities present in the ore. The impurities present in the ore we call it as gangue, and we may also use some different steps in getting the ore in the purest form, that is calcination or roasting. Calcination is a process of heating carbonate containing ores in the absence of oxygen. You can remember Ca. A stands for absence of oxygen. And the roasting can be done in the presence of oxygen. Sulfide ores will be taken as the selective materials and we convert them into their respective oxides. From the oxides we are going to reduce by taking carbon or any reducing agents. Then we will obtain the pure form of compounds. And here there is another important concept, that is thermite reaction. Thermite reaction, you learn these two equations wherein very high amount of temperature will be given out. It will be generally used in making the railway track fitted properly, and if any gaps are there, if any breakages are there, rusting is there in the tracks of railway or railway railing, then we can able to fix it by using this thermite reaction. Is one of the highly exothermic process which will be conducted. And here two reactions I have given, MnO2 plus Al, Fe2O3 plus Al. Both reactions you practice. It's similar only. The next one is refining of metals. There is whatever metals we are going to obtain from all this particular extraction of metals and enrichment of ore, they will not be in the 100% purest form. So to make it 100% pure, what we do is we do refining. One such important easy method is electrolytic refining, in which we take anode as the impure metal, cathode as the pure metal, anode mud as the impurities, and electrolyte we can select based upon the salt what we have taken. The metal salts only we will be taking as electrolyte. And last process is galvanization, which is used as a preventive measure for corrosion. The coating with a thin layer of zinc on the steel or iron materials is called as galvanization. So by this I hope this particular session will help you in revising the chapter 3 metals and non-metals for your board examination preparation. This is the final touch points or focus points for metals and non-metal, what you need to keep it in mind before going to final examination. I hope by this the first 3 chapters are very clear, and then will be certainly helping you in the final examination preparation. I will be coming out with the last chapter, that is carbonates compounds, in another 1 or 2 hours, so that it will help you in the final preparation easily. Keep watching the channel for more updates. Thank you.